the fact that there is something called a main rack, it means that we also have another type of rack in our PLC construction, and that is called the remote rack. So you need remote racks because if you run out of space on your main rack, you need to have your I/O being interfaced with the PLC on another rack, and that's usually why you'd have another remote rack. But then that remote rack must then be able to transfer the signals to and from the CPU. Also as well, if you have I/O that is located very far away where you have your main rack, you'll also want to have a remote rack in that area that collects information from the I/O in that area, and then the PLC remote rack will then transfer those signals to the CPU. Here we have our remote racks, and the number of remote racks can also depend on the specifications of your PLC, the number of I/O that you require for your plant. Also, depending on the PLC manufacturer, they can limit you on the number of racks that you can have for a particular PLC. It also depends on your comms media, so what type of comms technology that you're using for the main rack to communicate with the remote racks that you have in your plant. So these are some of the things that you need to consider when you're designing your control system in terms of the size as well as the space constraints. As well, you'd find that for a particular plant, the panel size is quite thin and you can't really get a nice wide enough rack for that panel size. That will constrain you in terms of the sizes of the racks that you can have, and that will then lead you to having a lot of remote racks for your particular plant. But the concept works the same. It's that this is our main rack because this is where the programming is. This is where the program lives, and then this main rack must be able to communicate with the other main racks on this particular control system or this PLC that you have here. Although there are a lot of components that are involved here, this is still one PLC and it is considered to be one PLC. It's just that it has a lot of inputs and outputs that it needs to get from the plant and also send to the devices on the plant. So the remote racks as well, their construction will be similar to the main rack, but the difference is that they do not have a CPU because this is the main guy. You can see it as a head, as an example. So your remote racks will still need a power supply, because if it's located somewhere else, then you can't use the same power supply to power up two racks. Usually that doesn't work, but I'm yet to see a technology where you can have one power supply for many racks. I'm not sure if it's out there, but you'd have your power supply, and this power supply is dedicated to powering all these cards that will be found on this rack. And what is important is that for a remote rack, you need to have a comms card. The main function of this card is that these racks must be able to communicate with the main rack of your PLC. If the comms breaks down, for example, then the main rack will not be able to see the two remote racks and whatever inputs and outputs that these two racks are serving in the plant. So those signals will not be able to reach the CPU, and the CPU will not also be able to control the field devices that are located on that particular PLC rack. So the main takeout so far would be that typical PLC construction, this is how it would look. You have your rack style configuration, and usually the rack will come empty, and then you'd have to slot in the number of cards that you need for your process. The top rack is called the main rack because it hosts the CPU, which is like the brain for your PLC. So you can look at this as this is the head, and these the other PLC cards are like the peripherals. Or for example, your brain is the CPU, and then your fingers and toes, your legs, they are the inputs and the outputs to what your brain is thinking when you are doing physical motion. So then if you want to then expand and grow your PLC, if you have a lot of inputs and outputs that you have in your plant, you then have another remote rack. Or if you have I/O that is located in another area far away from where the main rack is located, then you choose to have a remote rack, and the number of remote racks can expand as you expand the I/O in your plant.